that we've talked about so far. And whenever we see a rational function like this, and all these problems that kind of start you off, walking you through, find the vertical asymptotes, find the horizontal asymptotes, all that information is trying to get you the collection of ideas and concepts that are going to enable you to graph the rational function. So let's just kind of go through and do that stuff. And so the first thing we know we should always do is take that thing and factor, right? When I look at this, I see the top. Now the top is, you can use the A times C method right off the bat, but what would be an easier thing to do here with that top? Take 2 out. And taking that 2 out is going to leave you with x squared there plus x minus 6, right? And that is so much easier to factor, okay? X minus 2x plus 3, right? Okay, so there's my numerator. My denominator, what can come out of the bottom? X. Okay, that one's kind of easy. That one's a situation where we have a GCF, and then we take that GCF out, the greatest common factor. It's all the factoring we need to do. Okay, in the top there was a GCF there as well, right? That 2 was a GCF. But once we took that out, we still had to go through other options of factoring. But taking that GCF, that's why I always want to look at the GCF first. Because if I didn't do that at the top, I'd have to use the A times C method, which is more complex. It's more thought. It's more work. If I can take out the GCF, it now minimizes that extra work that I got to do. Okay. All right. So first thing I'm always going to do is I'm going to check to see if we have any holes here, right? Okay. And holes are created by common factors. So check for common factors. And do we have any factors on top that are the same as factors on the bottom? No. Okay. So none of those exist. The next thing I'm going to do is I'm just going to find vertical asymptotes. I think that's the easier thing for me to do when I've got this thing factored. And that's when we take the denominator and set it equal to what? 0. Okay. So we have x plus 1, that is equal to 0. So that gives me a vertical asymptote at x equals 0. And a vertical asymptote at x equals -1. Okay? Now, always trying to think about what does the current math provide me in regards to the next couple steps that I have to do. And once I see vertical asymptote of x equals 0, that is the same thing as what axis? The y-axis. So what does that tell me I will not have? I will not have a y-intercept. Okay, so that's always nice to think about. Okay, so as we come down here towards the end and we want to do y-intercepts, it's not applicable for this one. We don't have any. Okay, the next thing we're going to do is determine horizontal asymptotes. Okay, so this is the situation where we've got those 3 concepts, those 3 rules that we need to think about, and they're all based off of looking at those 2 things. Look at your leading terms, and then compare their degrees, right? So I'm going to try to compare that 2 with that 2. And when they're the same, I have to compare the coefficients up front, right? So I get a horizontal asymptote at y equals 2. Okay. Now, the question always arises, do we cross that? Do you cross the horizontal asymptote? And if you remember, all that is a system of equations. Whenever we have a curve and we want to know when does it cross another curve, we set them equal to each other. Okay? So, r of x, if you want to view that as a y, that's fine. But that y right there is the same as that y right there. So that means this stuff on the right-hand side is identical to the stuff that is on the right-hand side here, if they cross, right? Okay, so I'm going to take 2 and set it equal to 2x squared plus 2x minus 12 over x squared plus x. people always ask, did it matter whether you plugged that one into this process or that one in? Are they the same thing? Yeah, okay. But if I were to use this blue one here, this simplified one, this reduced one, this factored one, okay, in order to solve for x down here, I'm going to have to FOIL. And I'm going to have to distribute this x plus 1 back into this x and get x squared plus x. So it's always, when crossing horizontal asymptote, it is always best to use the equation that is expanded, or the rational function that is expanded. So now, multiplying this thing by a common denominator, I'm going to get 2 x squared plus x on the left. And when I multiply by x squared plus x on the right-hand side, this thing's going to go to 2x squared plus 2x minus 12. Okay, so 2x squared plus 2x is equal to 2x squared plus 2x minus 12. What is going to happen with that 2x squared and that 2x squared? Drop out. What about that 2x and that 2x? Drop out. So if everything on the left-hand side has currently dropped out, you're left with what? 0. And what you're left with on the right-hand side? Negative 12. And what kind of statement is that? False. Okay. So that tells me that we do not cross it, right? Okay. So cross horizontal asymptote? No. Some of you might be saying, man, that's a lot of work. That's something maybe I can gain from looking at a graph. And it's really not something you can gain from looking at a graph, because when you look at your horizontal asymptotes and you type this thing into y1, you look at your horizontal asymptote, just the pixels on your calculator, even on GeoGebra or Desmos, it's going to be really hard for you to go out to infinity and see if anywhere along there you've crossed it. Okay, so we, especially with the TI-83 and 84, with the display being so kind of pixelated. I mean, those displays are pretty bad. So the algebra is what we want to do to make sure of that. Okay. We have no y-intercepts. We need to see if we have any x-intercepts. Okay. X-intercepts occur where? Numerator equal to what? 0. Okay. So I'm going to take 0 is equal to, now the numerator was, I would suggest that you do this now with the factored form. So the factored form is 2, x minus 2, x plus 3. This provides me x-intercepts. Okay. Now, what would be the first thing that you'd go through here and do to solve for x? Divide by 2. And if we divide by 2, it goes away here, right? And what's 0 divided by 2? 0. Okay? So that thing wipes away, right? Okay? That's kind of the issue that people always ask. How do you know when you factor a GCF and when it becomes just a constant? When can you just let that thing go away? And when do you have to keep it? Well, if it's an equation equal to 0, you can let it go away because you're going to divide both sides by it, right? If it's just an expression that you factored, so it's like r of x equals 2 times x minus 2 times x plus 3, you have to keep it. Okay? But in the event now here solving for x, we've got that 0 over there, so we can divide by that. So that tells me x should equal what? 2 and negative 3. So those are my intercepts. And now we just have to graph it. So graphing this, my asymptotes were pretty close together. They were what, 0 and negative 1. So what I'm going to do is I'm going to go by 2's here. So there's negative 1. There's negative 2. Positive 1. Positive 2. We can do the same thing on the y-axis, I guess, as well. Got a question, Christian? The y-intercept, because they told us that, or I guess we went through the work and found that you got a vertical asymptote at x equals 0, right? Okay, so if I've got a vertical asymptote at x equals 0, that means we should have one of these dotted lines here, right? And that means we can't cross that, right? So if I can't cross that there, then there's no y value on that line, so there's no y-intercept. If you overlook that or don't see that or recognize that, which is fine. Remember, the y-intercept is always when x is what? 0. So if I go through here and I let x be 0, in my original one here, I get 0 there, right? 0 there, and 0 there, right? So on top, you got negative 12. On the bottom, you've got 0. And that's an undefined value, right? Can't do it. Undefined meaning that there will be no definitive point on your graph. There will not be a ordered pair anywhere when x is 0. So that's a good question. So we got 0 and negative 1. So put that asymptote in. We had a horizontal asymptote at 2. Put that thing in. X-intercepts were 2 and negative 3. Okay. What's really nice here is we know several things. We know we do not cross the horizontal asymptote, right? So because we don't cross the horizontal asymptote, and you can never cross a vertical asymptote, then we are restricted inside that region if this point here exists in that region, right? So as I move to the left, our graph should get pulled up towards that. And as I move to the right, my graph should get pulled towards that vertical asymptote. So it looks something like that. Okay. Now, obviously, to get more of a comprehensive graph, maybe a better idea of how fast this thing increases towards the horizontal and how fast it gets to the vertical asymptote, you could use some other test points if you wanted to. Plug in -4, -5, -2, -1.5 into your original function and get those test points. And the more points you get, the more comprehensive, right? But that's kind of a pain in the butt and really unnecessary for what we're trying to do here. Our other x-intercept was at 2, so would you guys agree that because 2 is right there, that we are stuck in that region? Because again, we didn't cross the horizontal asymptote. So as I move to the left, I'm going to go down to the vertical asymptote. As I move to the right, we'll get sucked up to that horizontal asymptote. Okay. Now we got to decide what happens in here when my x values are between -1 and 0. Okay. And everything, all the work that we have done didn't provide any points in there, right? But what we do know is that we don't have any other x-intercepts, right? So think about this. If I didn't have any other x-intercepts, can my graph exist in here? Because think about the understanding here. Think about the logic. If I don't have any other x-intercepts and I don't have a crossing of my horizontal asymptote, okay? So think of all the possibilities that could exist in here. Maybe you have a point right there, okay? Well, if I have a point right there, and I want to graph the rest of this thing, I got some options. I could go down, right? If I go down, I'm going to have to follow that vertical asymptote. But if I were to go down like that, what algebra should I have found previously that told me I could do that? You would have found another x-intercept. Okay? Now we know we don't cross this horizontal asymptote, right? So, because I don't cross that, I would have to do something like that, correct? So I really would have had 2 other x-intercepts that I would have found algebraically, right? So I know that my graph does not do that. I know it does not exist there. My only options are, because of the nature of no more x-intercepts, and because of the nature of not crossing the horizontal asymptote, I should know that my graph probably does something like that in that region. Okay? Because that validates the idea of no crosses for the x-intercepts, no crossing of the horizontal asymptote. Okay? Now, is that a great graph? I don't know, probably not. If you want to take in -0.5 and plug that in and see exactly where that shows up, you could do that. but in the event that I'm trying to match in WebAssign my graph to a solution, do I have enough? Yeah. Okay. So just quickly double checking that. Come to Desmos. I'm going to start to really like this calculator. 2x squared plus 2x minus 12. Divide. Nope, wrong one. Divide. Still not right. Parentheses. There you go. Okay, so when I first put this in, and this might have been something you see on your like TI 83 or 84, I first put this in, and my graph looks like that, right? It's not up until in the 50s. Looks like, I don't know, what is that value? To the half? Yeah, 0.5 comma 50. Do I see the rest of that curve? Does that make sense? So if you were to type this into Y1, you could probably just thought that was the graph you get and not know that you need to zoom out quite a bit to see that third region. Is everybody on the same page with that? That's why I like, understanding graphically by hand what we should be coming up with. Because now when I get to my calculator, I type in a rational function and I get that, I know automatically. Now there's another component to it. How do I find the other component? Got to zoom out. Okay, change my window. If they ask you for domain values, okay, domain values here, we're moving from the left. Okay, and we get to the vertical asymptote of -1, we have to kick that out, right? Okay. And then we include anything from -1 to 0, so we'll keep all that stuff. But then we got to kick 0 out, correct? So our domain is all real numbers except for -1 and 0. And then if they ask the range, I don't know if they do that on this question, but look at your y values. What's the lowest y value that you can use? -infinity. And as you move up, okay, what was this horizontal asymptote? 2. Okay, so if I got the line y equals 2 in here, okay, we know we're going to eventually get as close to that thing as possible, right? Okay? So I know my range right now goes from -infinity up to 2. Now, can I include -infinity? No. Can I include 2? No. So I put -infinity, comma 2, parentheses on both of them, right? Let me actually write this over here. We got -infinity up to 2. Now, we're going to union that because we jump this stuff, right? We jump all these values, these y values that are in here, because there's no ordered pairs in there, right? That have a y value being used. The first y value that we will see if we zoom out here, I don't know if I can. If I zoom out, the first y value that you see again was 50, right? Okay. Now, 0.5 comma 50. If I were to put 0.5 back into my polynomial, rational function, put it back into that, I will get 50 back. So that means 50 is on the graph. Does that make sense? Okay. So your y value of 50 is the next thing I find, and we should have a bracket around that one. And then we'll go to positive thing. That is our range for that one. Okay. They don't, and just general practice, I know WebAssign's doing it, but a lot of times, unless you are provided the graph in front of you, or have a technique to find the graph using technology or whatever, they usually won't ask you the range, okay? Unless you have the graph or the ability to find the graph real quick. Okay? Does anybody want to see anything with? First thing we want to do is factor top and bottom, right? So in the event of factoring top and bottom, it might make more sense for some of us to maybe write the top this way first. Factor out the negative. And then on the bottom, we've got our x, and then Well, x minus 2, that one's kind of easy. Just to kind of save some time right now, because this one here, x cubed minus 6x squared plus 5, to factor that thing, or to see if it factors against the real numbers, we would have to do P over Q stuff. Okay, and I just grabbed this out of the textbook, so I'm not 100% sure whether this one's going to factor real nice. So I'm going to, just in sake of time, kind of cheat here real quick. Let's go to our calculator here. We've got so I had x cubed minus 6x squared minus 5, and we're going to see if that thing factors. So we have to put the word factor right here. All right, so it spits back to me the exact same thing I typed in, so it's not going to factor down to our rational numbers, okay? Does that make sense? Okay, so let's just leave that alone. It's not a big deal if that doesn't factor any further than that, because we still can gain everything we need, okay? We can gain from this our x-intercepts, our y-intercepts, our vertical asymptotes, all that kind of stuff. The fact that it doesn't factor tells me there's not going to be any common factors. There's not going to be an x up here that will cancel with this x, so I won't have a hole at 0. There's not an x minus 2 up here that's going to cancel with this x minus 2, so I won't have a hole at 2. Finding vertical asymptotes, I think that might be the easiest thing to do here, vertical asymptotes. Okay, x equals 0 and x equals 2, right? It's taking this stuff here and setting it equal to 0. Okay. Horizontal asymptote, this is where the slant part comes in, because remember it's horizontal asymptote or slant asymptote. And if we look at these two polynomials, the x cubed on top and the x squared on the bottom, the one on top is bigger, right? So when the one on top is bigger, you've actually got to go through the long division. Okay, so I'm going to put negative x cubed plus 6x squared plus 0x minus 5. Well, you got to put that placeholder in there. And then out front, it's going to be x squared minus 2x. What do I need to put here? So when I multiply by x squared, I get negative x cubed. Negative x. So negative x. Now I multiply that out, I get negative x cubed. And then plus 2x squared, right? And I always go through and change these signs. And then I can add it straight down. So it's going to cancel. It's going to be 4x squared plus 0x minus 5, right? What can I put here? When I multiply by x squared, I get 4x squared. Multiply by that 4 to this stuff out here, I get 4x squared minus 8x. Change the signs. Becomes a negative, that becomes a positive. Now I'm going to add straight down. Just cancel out, and it leaves me with 8x minus 5, right? Now, do I stop there? Yeah. Because the only thing I can multiply then this by to get that is another rational value, essentially. Okay? So this tells me that quotient right there tells me that's where my slant asymptote is. Y equals negative x plus 4. Okay? And you would graph that like a line, because it is a line. Just back to algebra 1 stuff. The question is, then, do we ever cross that? We'll take negative x plus 4 and set that equal to my original polynomial. My original polynomial was negative x cubed plus 6x squared minus 5 over x squared minus 2x. I would then multiply both sides by that denominator, right? Okay, well, it's going to start to get a little bit ugly here. Negative x plus 4 times x squared minus 2x should equal negative x cubed plus 6x squared minus 5. FOIL this out, so I get negative x cubed. I'll finish this, you guys can go.
Have a good day.
Thank you, too. Here, okay, so that analog did work on that. That's easy.
Oh, Josh, I'm messed up.
Yep.
I got tricked.